So today we're going to learn about 1D kinematics and 2D kinematics. So please open up your PowerPoint, go through the PowerPoint as I go through lecture. Okay, so I'm going to reference the slides as I go through lecture. Okay, so let's turn to slide 2. The kinematic equations. Okay. Well, there's 5 kinematic equations there. Okay, so x naught equals the initial position, x is the final position, v with the bar on top is the average velocity, v equals final velocity, and v naught equals initial velocity. So that's what the variables represent. Okay, let's do a practice problem. So turn to slide 3. A kid steps off a 10.0 meter Olympic diving platform and cannonballs into the water below. When does he hit the water? Okay, so draw what you know. So a kid cannonballs off the Olympic diving platform. And this platform is 10 meters high. Okay, you always know that acceleration is going downward, and the direction of this velocity is also downward because he's going down. You know, the top, there's no speed, so v naught equals to 0. We're going to make the top y naught, that's where he starts, and this is where he ends. We're going to say that the y direction is downwards, so I'm choosing that the y direction goes on the path of the motion. So I'm making y direction positive. And y is 10, a distance of 10. And I'm going downwards, so it's positive 10. I'm going along the positive direction, so positive 10. Acceleration is going to be positive 9.8 meters per second squared, because again we chose y to be downwards, positive downwards. Okay, so it says when does he hit the water, so that's time. At what time does he hit the water? So we have the 5 different kinematic equations. Here's 3 of them. It's actually y instead of x because we're doing vertical direction. Okay, so for this first equation, we can't use it because we don't know what v is. We don't have v. Here, I'm looking for time, so I'm not going to use this equation because there's no time in this equation. So I'm going to use this middle one. Okay, so let's plug in the numbers to this equation. Final distance equals final position equals initial position plus v naught t plus 1/2 at squared. V naught is 0, so this goes to 0. So that's y is 10 equals to 0 plus, this goes to 0, so plus 1/2 at squared, so a is 9.8. And in our scenario, a is positive, so positive 1/2 times positive 9.8 times t squared. Okay, now it's just algebra, so we're going to multiply the 2 over, so 20, and we're going to divide this 9.8. So it's 20 divided by 9.8 equals to t squared, and then square root both sides. So t equals square root of 20 divided by 9.8. So put that in your calculator. So t equals to 1.429 seconds. Okay, so in 1.429 seconds, he's gonna hit the water. Okay, slide 4. How fast does he hit the water? So when he hits the water, what is his velocity? So now I'm asking, what is that velocity when he hits the water here? Okay, so we have the same conditions. V naught is 0, initial velocity is 0, y naught is 0. Same condition. So he goes down a positive 10 meters because it's along the positive y. And a is positive 9.8 meters per second squared. So what is velocity? Again, we have these kinematic equations. Which one should we use? What's the easiest one to use? So we want V. So we can use either the first one or the second one. Doesn't matter, but this seems the easiest right there. Simplest. So V equals to V naught plus AT. V equals to V naught. V naught is 0. Equals V equals to AT. V equals to 9.8 times 1.429. So that's 14 meters per second. So when he hits the water here, it's going to take 1.429 seconds and 14, and he's going to be at a velocity of 14 meters per second. Okay, and watch your sig figs. It's a 10.0, so make your answers 3 sig figs. Okay, so let us go on to the next part. Slide 5. So we've been doing just 1D. Well, so another type of problem is when you throw up a ball and then the ball goes down back to your hand. Okay, so how do we solve these types of problems when it's not just one, like from the ones we've been doing is just dropping down? So what if you throw the ball up and then it goes down? Okay, so look, see here that gravity is always down, right? Accelerations of gravity is always down. The direction of the direction of velocity is up because you're throwing the ball up. So velocity is upward, and then the ball's going to drop down, so velocity here is downwards. So on the way up, the ball is going up, so velocity is a upward direction. On the way down, the ball is going down, so velocity is a downward direction. So we want to be careful of what we say positive and what is positive and negative now, because now we're going to choose what direction is positive or negative. So you choose how you want to think of the positive and negative direction. Okay. Notice here, this is important, that at the top, the ball has no velocity. So at the top, there's no speed. So V equals 0 at the top. And the ball's motion is symmetrical about the maximum height. you see that there's symmetry in that motion. So the time it takes for it to go up is the same time that it's going to take to go down. Another thing that we're going to see is that the velocity is also going to be symmetric in a way. So if this starts at 10 meters per second up, at this height, the same height, it's going to be the opposite, negative 10 meters per second. And it's just going to go gradually to 0. So here, for example, if it's positive 5 meters per second at this height, then here it's going to be negative 5 meters per second. And up here it's 0. So because of the symmetry of the motion, this is the same time it goes up, same time it goes down. Times are the same, and velocity, velocity is the same at the same height. So if its initial velocity up is 10 meters per second, as it's going down back to the hand, it's negative 10 meters per second because of this symmetry. Okay, so next, let's turn to slide 6. So a person throws a ball upward into the air with an initial velocity of 10 meters per second. Calculate how high it goes, how long the ball is in the air before it comes back, how much time it takes for the ball to reach maximum height, and velocity of the ball when it returns to the thrower's hand.